Hey guys, how's it been going? This is JSer. Today, let's take a look at 442. Find all duplicates in an array. Given an array of integers, some of the elements appear twice. N is the size of the array. Some elements appear twice and others appear once. Find all the elements that appear twice in this array. Well, I think I did something similar before about finding the duplicates. It's a nice trick is that keep swapping. So when we meet a number, just try to swap it to the right position, like we have an array like this, right? So what we do, we just loop through the elements from index 1, 0. So we find a 4. So obviously 4 should not be here, right? It should be at the 1, 2, 3, 4 should be at the position of 7. So we swap them, right? So this position 1 is not settled, and we have 3, 2, we swapped, so we have 4, and then 8, 2, 3, 1, right? And then we keep looping on the first element is 7. We should put it at 7, right? So the 7 is here, 3. So what we got here is 3, 3, 2, 4, 8, 2, 7, 1. And okay, so the first element becomes 3. It's still not the right position. We swap it with 1, 2, 3. So we got 2, 3, 2, 2, 3, 3. Okay, here, right? Yeah, so now 3, 4, 7 are at the right position, right? And now we got 2, so we need to swap 3 again. So what we got? 3, 3, 2, 3, something like this. Okay, still, this is not the right number, right? So we swap it to 3. We meet 3 again. When we swap 3 to this 3, we find that, okay, there's already a 3 at the right position. So, yeah, we are trying to put 3 at the right position, but there's already a 3, the same numbers at the position. So this is a duplicate, right? So we ignore it. So 3 is our target, right? So 3 is duplicate, so we skip it. So we do nothing, and we find 3 and 2, 3, 4. Now we go to 8. We got 1, right? 1, 2, 7, 8. Now we check 1. We check 1. Okay, 1 is here. So this is a problem. Okay, we check 1. We got 3. But 3 is already invalid. I think I should mark it as a duplicate. So I should just put it there. So 1, 2, 3, 4. We do nothing, and 3, 2, 7, 8. Right? 3 is already collected. This number. We know it's duplicate, so we do nothing because we're switching numbers from this position to another position, and it is 3. So yeah, we could just swap it and ignore it and go to the next one, right? Because next number couldn't be here. Or could. If could, we could just do the same, right? Because 3 is our target. So our solution would be keep swapping to the right position. If same number meets, then duplicate. When duplicates, we do nothing, right? Okay, so we find these 3. We're trying to put it to here because it's duplicate. We do nothing. Cool. So this is it. Let's try to do it. Okay, we keep track of result to keep track hold all the duplicate numbers, and then for that I equals 0. Okay, the index actually start with the base 1 from 1, right? Here we start with 0. Okay, I'll say while nums I, which is the number, is not I plus 1. So the first number, if it is not 1, we'll try to put it, try to swap, right? So we need to, the target equals nums I. We need to put nums I to I plus 1. No. We should put if it's 1, we need to put 0. Yeah. Nums I to nums I minus 1 at the index, right? So if it's the same, we find as we analyzed, if it's the same, we have a duplicate number, right? Because some exact twice, there's no third time, something like that. Okay, so the number at target position would be, okay, no, the right index would be nums I minus 1, right? If the target number to swap is the same, if it is our number, which is nums I, then we find a duplicate number, right? Which is nums I itself. And then we could, we already find it, so we need to break, right? Yeah, we need to break. So continue. So we break. Cool. And if it is not, we need to swap it. Which means nums I, nums right index equals nums right index, right nums I. Cool, so we swapped and then keep check, right? So finally we will find a 1 or 3. And we go to the next one and do the same. So yeah, this is it, I think. Result. Before I run the code, allow me to review my code one more time. Yeah, so for the input in for the example here, okay, the initial case would be like this, right? So we go to 0, 4, and then because 4 doesn't equal to 1, right? We will continue this for loop and get the right index, which is 4. Here should be 3, 0, 1, 2, 3, 7. Because it's not the same, we swap it. Swap doesn't. Okay, and then we continue this check. 3, okay. Okay, 7, 3, 2, 3, 3. This, until here, it's right. And then we swap 3, 2, 3. Okay, it's right. And now we got 3. 3, the target should be 2. It's the same, right? It's the same. So yeah, we should put 3 here and go to 2. Right? Okay. Something here. Yeah. Wait a minute. 3. Yeah, go to 2. Wait. 2, 3. Okay. 3, 2. Okay. And we found it. So we break. Go to 2 again. Here. And then 2 should be put at 2 itself. So it is at the right position. So we should skip to these 3, right? So it should be we should while, because it here while loop, because it is not 2. Yeah, it is our target. So we continue to next one. Go to 3 here, and it is, so we go to 4. And 4 it is, so we go to 1. It is not, we go to 1, 3. And check 3 again and find it. Here's a problem. When we find a 3, we push it, so the result actually will be 2 3s in it, right? This is not good. I'll use a new set. So add it. Okay. Now we go to 2. 2 is 2. Okay, we add it. So 3, 2 in it. The output is, does the order matter? I don't know. Let's just return the result. Oh, accepted. So actually the order doesn't matter. Let's submit. Great. So the time complexity for this one, actually, time we just do swapping. So this is a linear time. We traverse through our index, and while here's a for loop, but actually every time if we continue this while loop, actually it will reduce the another while loop, right? So if we swap one element here, like 4, swap to here, then when the I equals 4, then the while loop is gone. So actually it's linear time, right? Yeah. So totally it's linear time. Space, yeah, we use a set here, but it's the result, so I think it should be constant. How can I say? Yeah, at last we need a linear space, right? So this actually doesn't matter, so it's constant time, auxiliary constant time. Cool. Wow, this is a new feature debugger. What is this? Ooh, wow, this is cool. This is the first time I see it. Okay, let's say add a debugger here. What's gonna happen? No. Debug. Oh, cool, man. This is cool. This is cool. Wow. That's cool. Just cool. Okay, so that's all for this problem. Hope it helps. See you next time. Bye bye.